please label your notes similar triangle theorems. Last week we talked about 4 congruence theorems, 4 triangle congruence theorems, 4 of them. Can someone list or name one of them for me? Go ahead, Mike.
Side, side, side.
Side, 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 SSS. So you can use SSS if you would like to prove that 2 triangles are congruent. What's another one? Go ahead.
SAS.
SAS. Another one.
AAS.
AS. A. And there was AAS. There were 4 of them. These are the 4 that you can use if you are trying to prove that triangles are congruent. But we're not talking about congruent triangles anymore. We're talking about similar triangles. Similar triangles have equal angles, but they have proportional sides. So all 4 of those theorems don't work to prove that triangles are similar. They only work for congruence. There is another, there's 3 that work for similar. The first of them being brand new to you. It's called angle-angle. Angle-angle similarity.
No.
And that means this. If you have a triangle, go ahead and draw yourself a triangle. Draw another triangle right next to it that looks like it is exactly the same shape but a different size. According to the angle-angle similarity theorem, if you can get 2 angles of one triangle to be exactly the same measure of 2 angles of another triangle, then the triangles are similar. It's called the angle-angle similarity theorem. So mark that angle the same as that angle. Remember, in similar figures, the angles are equal. It's the sides that are not equal. The sides are proportional. But we also know that that angle is equal to that angle. If that's all you know, the triangles are similar. They are similar. There's another one. So the first is angle-angle. The one that people usually like because it's quick and easy. If you can get 2 angles equal to 2 angles, you're done. Side, side, side also works for similarity.
Nice.
It's called the side, side, side similarity theorem. And that says this. You have 2 figures. They're the same shape. They're different sizes. But according to SSS, you don't need to know anything about the angles. If you will only know things about the sides, that's enough to show that the triangles are similar. But they all have to be proportional. So let's say that this side is 3, and that side's 4, and that side's 5. It's a very famous triangle called 3, 4, 5 triangle. Does anybody know what's true about the angle in between the sides that are marked 3 and 4?
It's 30.
No, it's 90. And the reason it's 90 is because if you guys do a quick check on your calculator, the Pythagorean theorem works here. If you take 3 squared plus 4 squared, you will get 5 squared. Since that works, that means that there is in fact a right angle there. That's more information than you need right now. But if you know those 3 side measures, and then over here, you know that this is 6, and this is 8, and this is 10, the triangles are similar by the side, side, side similarity theorem, because if you take this 3 and you match it up with this 6, 3 over 6, you will get exactly the same thing if you take what divided by what? 4 over 8. Very nice. And you will also get the same thing if you do what over what? Very good. If you take this 5 and divide it by that 10. By the way, it also works backwards. You could take the 10 and divide it by 5, and you would get the same thing if you took 8 divided by 4, and you would get the same thing if you did 6 divided by 3. So all 3 of these would have to be equal to each other. If one of them was not equal to the other 2, the triangles are not similar. Okay? So if this ends up being a true statement in the triangles that you are working with, the triangles are similar by SSS. One more theorem and then we're done for the hour, by the way. Ready?
Mm-hmm.
And I flip pages.
Yes. Yep.
The other one is called SAS.
Nice.
So yes, side, side, side works for congruence. It also works for similar. SAS works for similar and for congruent also, and that can sometimes get confusing. Go ahead, draw yourself 2 sets of triangles, same shape, different size. And according to this, there has to be an angle equal to an angle. So let's say it's this one.
Wait, what?
I'm sorry, what?
Side equal to side?
What'd you say?
Wouldn't it be side equal to side?
No, remember the sides, but similarity, the sides are not equal, they're proportional.
Oh,
That means if you set up their fractions are equal. But the angle, the A in the middle, is equal to the other A. So let's say this angle, we're talking about this left angle in the first triangle. Which angle does it have to match in the second triangle?
Same one.
Yeah, the same one. Gotta match that one.
Gee
So the
willikers.
angles have to be equal. And then, I don't know, I'm going to make up some numbers here. Let's say that this is 7, and this is 8. And then over here we have 21, and we have 24. Do you see the order here? We have a side. So if I rotate around the circle, I have an angle. And I continue to rotate, I have a side. So I have a side, an angle, and a side. So in that order, SAS gets me the similarity theorem, or the side angle side theorem. Same thing over here, I have a side. As I rotate around the circle, I have an angle. And I keep rotating, I have a side. So in that order, excuse me, SAS. In that order, yes. But just because they follow that order doesn't mean they're similar. You have to check to make sure that those ratios are equal to each other. So if you take 7 and you divide it by 21, this 7 divided by that 21, do you get the same thing if you take 8 and divide it by 24? Is that a true statement? Is 7 over 21 exactly the same thing as 8 over 24? Yeah, I think you get a third. And you get a third. So that is a true statement. So those triangles would be similar by side angle side. Questions? Do you have anything you want to ask?
Nope, I'm good. I
You
got
good?
it. I got it all.
You got it all?
Yeah.
What are the 3 theorems?
Don't put me on spot. Don't put me.
Well, here's one.
Yeah. Oh yeah. SAS and then it's AAA and then it's SSS.
Good.
But she gave me the answer.
I didn't know she was talking about. I was trying to like tag me.
You look like you're struggling.
I didn't stop recording.
So
You did?
This is all gonna be
They
recorded.
want to hear me.
Hola.
Actually struggling.
Yes, they are. There we go.
Technical difficulties.